Hey everybody, this is the Alex Manassa, and if you've watched the previous video, which I'll put in the description, we made a symbol in KiCad, and that symbol was for the AP3032 right here. Now, we just need to make the circuit, right? And to make the circuit, what we're going to need to do is we're going to have to look at the data sheet, which I have right here, and find the application circuit. Now, this thing has a topology that's very similar to a switch mode power supply, and it probably just is one that's, current controlled, with current feedback. Looks like we have a voltage in. For example, in this one it says 5 volts, which is fine. It might not necessarily be the voltage we have in. We've got an inductor off from the V into the switch pin, and then we have what is a Schottky diode. Now, it looks like a Zener diode. It is not. If you look up at the pin table up here, it says Schottky diode. Schottky. Okay? Now what that means, the reason why I use a Schottky diode is it has very low forward voltage drop. Remember, P equals IV, right? Now, if you have a certain voltage drop on a diode, if whether it's 2.5 volts or 0.5 volts, you have to take that voltage, multiply it by the current that's going through it, and that's the amount of wattage that it needs to be able to dissipate, okay? So if you have like 0.5 volt forward voltage on the Schottky diode, and you have 2 amps going through it, that's going to be 1 watt of dissipation required, okay? Same thing goes for the inductor, but really you can just look at the current ratings for the inductor. These are feedback resistors, so it's not that important. They'll probably be 0805s or 0603s, no problem. Yep, and a capacitor, which is just there to provide decoupling, right? It's the usual stuff. All right, so what we're going to do here is we are going to go ahead and make this circuit in KiCad. Okay. Now, I've already put the AP3032 and 2 resistors in, and now I need to place a symbol for a Schottky diode. So I'm just going to type into this filter here, Schottky. It's right there. See, I told you the symbol looks a little different. Schottky diodes usually have this little curlicue at the end. Little kind of looks like an Egyptian hieroglyphic person. Okay. Put them in here, rotate them. Okay, we did it. All right, all done. We can go home now. Just kidding. I'm already home. I used to stay up late nights making circuits when I was a wee lad. We don't want a PSpice model. This is the PSpice library. We don't need a PSpice model. We just need an inductor, okay? And the inductors, for some strange reason that is actually beyond me, have a symbol of L. I don't know why. It's not even... After a while, you just run out of letters in the alphabet, okay? It is okay. It's okay. All right, we want capacitor. Alrighty, now I'm going to take these capacitors here, and 10 microfarads, you can get that in a ceramic. I'm sure you can. I'm not going to be too... this is capacitor and capacitor polar. So capacitors have to maintain an electric field between 2 plates. You can see the symbol looks like 2 plates, right? Well, sometimes to maximize the dielectric constant. All right, so the dielectric constant is a property of a material. It's pretty much how much electric field can exist on that for amount of, how much electric field can it take before it has a breakdown, okay? So if you have in between free space, you have a dielectric of free air, that's about 1,000 volts to make it 1 inch to short through it. That's the maximum voltage you can have. If I put some sort of chemicals or a layer of Teflon or something like that, I can actually get these 2 plates way closer and get a higher voltage, right? Now, sometimes the way you do that is by putting a chemical in there that makes it so it's, different chemical makeup that makes it so it's has a certain polarity, as in there's a plus and a minus in the capacitor. If you violate the polarity, it will explode, and it'll smell really bad. And it'll concern everyone. Now, 10 microfarads, it's pretty realistic to get a ceramic, and a ceramic is non-polar. All right, it just has a ceramic material as the middle material there. Oh, hey, Blue. What's up? What's up, cuz? Let me see if Blue's in frame. No, he's not. You want to say hi to Blue? Hi, Blue. No? Okay. I'll tell you what, you can co-pilot this. He's probably going to crawl everywhere. Okay, I got myself a co-engineer, and he's already buggered off. That's what happens when you have group projects. All right, now we need to put an LED here, which we're going to go ahead and put our special LED. Now here's the part where it's going to get a little funky, because we're going to need 4 of these circuits per LED. So actually, I'll tell you what, we're going to use an off-board connector, or sorry, a global label is what they call it here, to keep things sane. So I'm going to call this LED01, and I'm just going to name it R. Okay? And that's going to be it. Actually, let's go ahead and move that up here so it's in line with the rest of these. Let's tighten the circuit up because we're going to have a lot of these circuits. We're going to need one of these circuits for every single LED or diode inside of those LEDs, the RGBWs. So we're going to have 4 of these circuits per LED, and there's 25 of those LEDs, so that's going to be 100 of these circuits. Which strangely enough only comes up to like $10 for chip here, and then there's going to be the rest of these little parts here. Let's go ahead and put a ground in because we like to stay grounded around here. That is power port. Okay, I don't need a P-Spice. I just want to go down to ground. Yeah, ground, that's fine. There you go, get my ground symbol here. Let's check on that schematic, make sure I'm getting this right. All right, so we got our bypass capacitor on the input, 10 microfarads. We got the input also V in. Okay, so I'm going to go ahead and also just grab another power input. How about that? And we're going to call this VCC. That's voltage collector collector. There we go. This is a pretty European-centric software, so there's very European-centric symbol schemes. So the symbols are going to look a little bit different if you're from the States. I'm from the States. I work for a German company though, so yeah, you get used to it. The resistors don't have squiggly lines. Resistors just look like a little box thing. Is that right? Okay, and then the feedback goes to the LED. Got it. Okay, so actually LEDR is not just LEDR. It's got to be LEDR and then anode. Should I say plus or should I say anode? And I'm going to put anode. And I like to put the thing I'm going to change a lot. Oof. All right, LED anode R01. How about that? Okay, so that way I don't only have to change the last 3 letters, everything else. I don't like to change the middle of letters. I like to be able to look at, okay, what is this? And then at the very end, that's the sort of serialization, all that. It just keeps things neater, nicer. Where'd my cat go? All right, whatever. I'm sure he's not up to no good at the moment. Okay, now this FB, which stands for feedback, not Facebook. I gotta move this down, so I need to grab these. Can I do it? It's gonna be a little. Let's see, G. Okay. Whatever. I'll take the L for the moment. Just get this over with. All right, connect these guys. Ground. It's good to make it look like the schematic that you're given as much as possible. I'm going to grab this, move that down. Okay. And I'm going to name this guy. I'm going to call it Control R01. Sure. Ta-da! Alright, in case you can't see it. Alright, feedback is right here. We're going to take that, and we're going to give that to... We're not going to have these be the same. I'm just doing this because I'm lazy. Alright, can I... There we go. This is the cathode. Cathode. Yes, okay. We're doing... Okay. So I got anode, cathode, and... Alright. Alright, I think that's good. Oh, and there's going to be a current limiting resistor. I'm going to put that... Yeah, okay. Alright, I'm going to go ahead and put that in here as well. Oops. I'm just going to put my mouse over the component and hit C. By the way, if you put your mouse over any of these components and then right-click, you can see all these different hotkeys that you can press. You can just press those at any time, and you don't even have to right-click. So if I want to just drag it, I'll hit G. If I want to move it, I'll hit G. What's the difference between dragging and moving? Here's a move. Part goes... And here's a drag. So you see the difference? Okay. I'm going to connect you there to there. All right, cool. Okay. Now, is this going to get me what I want? I think so. Because if I look at the data sheet, what I want is current control. That's going to control brightness, roughly speaking. Though I'm not sure if anyone's going to notice. Feedback voltage. So PWM. Yeah, I'd rather just control from the control. Yeah. We're still going to dissipate 10 ohms, though. Is that what you want? Well, I guess we're going to find out. It feels terribly wasteful either way. Okay. I'm just reading through this, getting a feel for it. Feedback. Secondly, changing the feedback voltage to get the appropriate duty and luminous intensity is also useful. Gotta love that passive voice. Controlling control pin to change. Okay, is a good choice. It's also useful. That's a good choice. And it's also useful to do this. Alright, LED current control. Refer to figure 21. 21 is on a completely different page. Okay, alright, so, okay, do that. LED's current accuracy is determined by the regulator's feedback threshold accuracy and is independent of the LED's forward voltage variation, so the precise resistors are preferred. The resistance of I set is in inverse proportion to the LED current since the feedback reference is fixed at 2. Okay, so it's going to fix the FB pin at 200 millivolts. And, okay, the lower you have that resistor, the higher it's going to have to pump the current to keep it at 200 millivolts. Got it. Yep, exactly. Okay, so right here. So ILED, if I want to do a calculation really quick, let me see if I can bring up my calculator. So if I'm giving this LED, it doesn't have, okay, it doesn't matter what the input voltage is. Okay. So if I take 0.2, which is 200 millivolts, divided by, I don't know, 10. Okay, that's the 200. All right, so that's 20 milliamps. Now, if I make that really small, like 0.2 divided by like 0.1, right? That makes it 2 amps. Okay, so 0.2 millivolts divided by 0.2. Yeah, all right, well, this will definitely give me 1. So if I wanted 1 amp, all right. So it's going to be a big old doozy of a really small resistor, so like a 0.2 ohm. So if I have 0.2 ohms times 1, oh wow, that's still only like a quarter a watt. Okay, well, that's incredible. Can you really get it? Wow, can you get away with that? God dang. Yeah, so, wait, it's I squared R. All right, well, I is 1, so 1 squared is 1 times R, which is 0.2 ohms. Okay. All right, I feel good about this. The math works. The math makes me feel good. I can sleep at night knowing that the math works. You do not know the struggle of their math not working. All right, I haven't given any of these values, but you know what? Cool kids, just give it the old. Also, cool kid. 178. No, I forget what it is. 0181. I'm using the shortcuts. If you hold Alt and then go to your number key, your number pad. Hold Alt, go 0181, and it'll put a micro, and everyone's going to think you're super cool. No, they won't. They won't. I'm going to leave this as D Schottky. I'm probably not even going to make the D Schottky visible on the circuit board. All right, what do they want? R1 and R2. What determines that? What determines R1 and R2? I wish they'd give me some values in here. All right, so overvoltage protection. Okay, the AP3032 has an internal open load protection circuit. When the LEDs are disconnected from the circuit or fail to open, the output voltage is clamped at 27 volts. The AP3032 will switch at a low frequency and minimize current to avoid voltage input drop. Okay, so this is... Okay. So it's trying to prevent it. If a LED fails open, that means it's blown up. It's killed itself, which means the entire string that it's on is not going to work anymore. Which means that it'll probably put a lot more current on the other. Yeah, if it's current controlled. But I only have one LED, so I don't really care. What I want to know actually is input voltage. Is it 2.7 to 9? Okay. Yeah, okay, wow. So if it's 2.7 to 9 volts input, actually the best thing for me to do might be to use a really beefy battery, like a 3.6 volts, lithium ion battery. I gotta think about that. I mean, I've got one of those in my high-powered flashlight for my shotgun. Alright, I'll think about that. I still don't know what the values of R1 and R2 are, so... I'm still clueless. What do you want me to do? I just want an answer. Just tell me what you want me to do. I don't want to have to learn new things. Probably don't have just R1 on here, do you? Yeah. Resistor. The voltage on sense resistor is proportional to the switch current, the output of the PWM. Okay. RI set. Okay. I have no idea. I'm going to sit and do some math. Alright, let's see what the OV pin is. Okay, so if the OV is trying to hold it there at that voltage, OVP voltage is 27 volts. Okay. Okay. Does it have a recommendation? Over voltage protection input, connect to the output direct. It says connect to the output directly. On OVP condition, the output voltage will clamp. Oh, okay. So there aren't really resistors on this. This is pin 5. It says connected directly. Alright, I'll tell you what. I'm going to put a JMP, and on this one I'll put a DNP. A do not place. So this one's a jumper. It's a short. I can also just put a 0 here. And then DNP means do not place. So just pretend that there's a line, a wire here instead of a resistor. And then on here, pretend the resistor's just not there. Okay, we get a little more straightforward answers on the capacitors, which I believe was 1 microfarad output. Yes. Again, alt 0181 farads. Okay, and you here were 10 microfarads. Cool. Very cool. Wait a second. Why have I not? Oh, okay. Let's drag this hotkey just a little bit. And we're going to go ahead and make a wire right here. I like to come out 1 unit at least, just to make things look good. Okay. Now we can tighten this up a little bit. So let's do that. Okay, I'm going to tighten you up. Actually, I could just flag you right there. Now, I know I'm not going 1 unit out like I said I was going to just now, but that looks pretty good. We can also probably bring all these up a little bit. So grab you, drag you up, grab you, drag you up, drag you up, drag you up. There we go. Our circuit's a little smaller. Now the reason I'm trying to make this circuit small is because I gotta have 25 of these. And it'd be nice to fit them on 1 sheet of paper, but it just may not happen. We'll see. That's definitely not gonna happen. I wonder if I should just make these as like really tiny boards, you know, and just chain them up, you know, make a chain of them. Yeah, it would be a lot easier from a package perspective, I think. All right, well, I'm going to need at least 4 of these, okay? So I'm going to just select all this, and I'm going to hit the C. Oh, okay, that doesn't work. Okay, now, all right, so I've selected all of it. I'm going to duplicate the block. Oh, wait. What is the difference between duplicating and copying? Okay, let's duplicate it once. How's that feel? Does that feel good? Okay. It's going to copy it once. Copied it. Oh, okay, now you have to paste it. I got it. I got you. I've got you. Okay. Almost. Alright, well, that's not going to work out. So let's just keep you aligned. Oh, I really like having... Yeah, I really prefer to have... I really prefer to have this so that the incrementer for all these part designations is incrementing from circuit to circuit. So if this is going to be R1 and then this is R2 and that's R3, I'd like this to be R4 or 5, 6. I don't want this to be like 1, 2, 3. All right, you know what I'm saying? So, all right, there we go. You'll see in a minute. Okay, so I'm going to now rename these. So R is correct. Next one, I'm just going to change this to G. Now I'm going to rename these to B. Wait, did I screw up? Did I say B and then hit G? It's entirely possible. I'm very tired. I am very tired. All right, B, and I don't have to populate all these because what I'm doing is I'm just laying out the circuits. I'm not actually going to necessarily populate these. So if I don't want to use the white, I don't have to. But here's the white. All right, and I'm going to use a dev kit, probably a Cypress dev kit, to go ahead and control all of these. So here's the control. So I got to do all the controls now. Control R01. This needs to be G01. Control B01 and control W01. All right, very good, very good. Okay, let's go ahead and assign. Now there's a footprint for, well, let's finish placing everything first before I start fussing around with footprints. Custom. Here's the LED I designed. This is going to be fun and easy. Okay. So where is the R? Here's the R. Okay, where's the G? There's the G. There's the anode. Remember anode, you can remember it as anti-negative, so it's positive. Anode is positive. And cathode is, if you don't like cats, that's an easy one to remember because cat is negative. I mean, cats can also just be negative and you still like cats. It's kind of the beauty of cats. And then white. I don't know why. I just spun it around for no reason. I'm going to drag all the... okay. I might as well just grab all of them then. Okay. I like to have a little bit of wire. Unless it's a trade-off between what's going to be uglier and what's going to be the ugliest, right? There we go. White anode, white cathode, green anode, green cathode, red anode, red cathode, blue anode, blue cathode. All right, we're there. Okay, cool. So we've got all that going. Now I need a connector. Let's make it we're going to need a power supply. So we're going to need VCC. We're going to need the ground, of course. We're going to need 4 control lines, and I think that's it. So we're going to say symbol. We're going to place a symbol. We're going to go over to the connector library here. Connector, and we're going to just go find ourselves a nice generic rectangular connector. I remember this taking a long time actually last time. Oh, whatever. Here it is. It's just con. Okay. Doesn't matter if it's female or male. I mean, really, in the grand scheme of things. I don't know. You could choose a male if you want. So what did I say? 4 control. All right, so 6, right? 4 control lines and then power and ground. Easy peasy. Do I want this to be male? Yeah. Okay. So I'm gonna go ahead and put male header pins on this. What we say in the business is that females have the power, right? So if you have a female connector, it is. I wish I had a model for you. I mean, I don't know how this is gonna play. So let me just change over to my headshot. This is a female connector. I don't know if this is gonna autofocus or not. Just try to get out of the way. Maybe. Maybe no. All right. Well. Dang it. Let me just hold a female and a male up against each other, right? So here's a female and a male. I know it's not great, but you see that the male right here has a pin coming out. It's going to go into the female, right? Guess how they got that name for the convention there. Females have the power because I can't make the metal contacts in these hit each other and then cause a spark. Whereas if you have a bunch of males, they've got a big exposed piece of conductor and they will cause a spark. They will cause a short circuit. So that's why we give females the power, because they can't cause a spark so easily. So this board is on the receiving end of the power. So that is why we are going to give it all of this stuff. All right, now here's another thing. I don't like to make connectors so they can be connected wrong. In this case, I don't think it's going to matter that much. I don't want to be able to reverse power and ground if I connect it in backwards, right? So what I'm going to do is I'm just going to take the red control. I'm going to put it in pin 1. I'm going to take VCC. I'll just grab VCC over here. I'm going to put it on pin 2. This is probably unnecessary, but it makes me feel better. It's just a habit I got into. I'm going to go ahead and put ground on pin 6. Did I pick ground A? Is that really? Okay. That way, if you plug this in backwards, it'll switch 1 and 6, 5 and 2, 3 and 4. You'll be putting power on pin 5, and you'll be putting ground on pin 1. It's not the end of the world if you do that, I don't think. If I really wanted to, I'd pick a 7-pin connector and put VCC in the middle, and then like maybe a ground on either side or something. That's a truly reversible connector when it's actually functional if you reverse it. But I'm not doing that. I really actually have very little concern of me reversing this. It's just for lab use. You know, if this was being handled by somebody else, then I might be a little bit concerned and try to make it real idiot-proof for them. Okay. I don't really care what to call it. I don't really have a value for this. Okay, it's going to go ahead and grab this symbol, and we're going to go to its properties. Now we can go ahead and start assigning footprints. All right, now if you've been on a few of these videos before, you'll know that all you got to do is go to connector, and I think it's rectangular, connector pin. No, that's not it. Connector pin header, 2.54. That's the 100 thousandths of an inch pitch. We're going to go to the 6 pins. And we're just going to pick this guy. Looks as good as anybody. All right, so that has a footprint. The SPF05 FOB already has a footprint, I believe. Yep, already picked it out, so it's good. The Schottky diode and inductor, I'm going to have to shop for those. I mean, we could pick those like right now, but I'm not really too plussed about it. Resistors, I'm just going to jump in and say they're going to be 0805s. That's a pretty beefy resistor. I think we can handle it. So I'm going to go down to RSMD. Or is it SMDR? I don't remember. Here it is, resistor SMD. Okay. I'm going to pick out the 0805. Sure. And I'm going to copy that for every component in this. I probably could have done some copy-paste magic beforehand and save myself the trouble, but that's not my style. I just assigned it to the power resistor. I don't know if that's true. It's a good question. I think I might want to go a little bigger on that one. 1210 is pretty good. I think they're going to have... And if you want to go 12.6, that's just slimmer, so you just have more space. So 1210 is a safe bet for a power resistor. So I'm going to grab the 1210, and I'm going to just put it on everything. I think 1210 gets you up to half a watt. I don't remember. I mean, also, I'm sure they come up with more power-dense resistors. Maybe. You're probably more likely to come up with resistors that have material properties that can handle the high temperatures than to change the laws of physics. I mean, your power dissipation is going to be entirely about your size, right? That your surface area contact with the outside world, including the circuit board itself, right? It's you pressed up against the wind and the circuit board itself, everything. Okay, did I do a good job? All right, now I know for 1 microfarads you can do a 0805. You can do an 0603. I mean, there's nothing that's stopping you. So, diode. Why do I have such trouble finding stuff in here? Oh, here it is. Capacitor. Now, when they say tantalum, oh, these are the polars. So they're showing some polarity. CP means C polar. Tantalums, I don't know why they have special symbols for that. That's because tantalums are more rectangular, I guess. Oh, here we go. Okay. Here's 0805. Notice how it's exactly the same as the resistor. There's zero difference. Zero difference. Oh. I got a middle click and drag, not... Also, that's the resistor I just pressed. Can you tell I'm a little tired? That's all right. We'll power through it together. All right, so I've assigned some footprints now. I think we're going to have to go shopping, okay? I didn't put a ground on any of these. I can fix that easy. There we go. Yeah, don't forget to put ground on your circuits. You'll be floating. You'll be floating around. Okay. So the only things I need a footprint are of the first capacitor, the inductor, and the Schottky diode. I think I can actually probably do all that. Okay, so I'm going to go to DigiKey. Why do I choose DigiKey? They got a really good selection. That's it. That's the reason. I just like to only shop at one place. All right, let's do capacitors and inductors and... Oh, where's diodes? I know you're here. Nope. Okay. There we go. Diodes, and I want to be singles. Why am I not seeing singles? I got bridge rectifiers, which I don't want. RF, which I don't want. Rectifier arrays, which I don't want. Rectifier singles, which I don't think I want. Varicaps, don't want. Zener, don't want. Zener single, don't want. What's going on? Is that okay? I guess I don't... Diodes rectifier single, right? Yep, that's the 1418. That's a pretty famous one. Okay, cool. So it's under diodes rectifier single. It's like diodes / rectifiers. I'm going to go for in stock. Always do in stock first. You don't want to be sorting out a bunch of stuff that you can't buy. So we start with in stock. I'd rather get something that's active. That didn't reduce my selection down. It was 11,300 something. Now it's 10,300 something. Close enough. I want a Schottky. I don't want reverse polarity. There's no point for that. That's kind of cool, though. Silicon carbide, I think, is for really high voltages, so that's just unnecessary. Right, okay. I want surface mount. All right. Okay. 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 Current average rectified. Oof. I'm going to need more than that. Good Lord. I want to overbuild this thing because I don't want to. I'm gonna see what we're gonna see what happens. All right, so I'm gonna grab everything from 1 amp to 50 amps, pretty much 1 amp on up. I'm just gonna see what price I'm looking at. Where's the price? Oh, there it is. They moved the price over the front. That's new. All right, so I've sorted by what? What? Wait a minute. What just happened? There was a price there, and now it's gone. Okay. So why does it say active? Active is not a price. Okay. That's how many of these are just called active? That's very strange. That's very strange. All right. Well, I want a lot of these. I want at least 100 of them. So let's do that. Can I hit enter? Make that happen? Oh, hot dang, I guess I can. Why does it say active and 100? Oh, it says minimum quantity, 1500. Well, I don't want that. Yeah, what the heck? Okay, that's probably why it doesn't want to say what the price is. Okay. So, $1. Wait, how is the lowest price for one of these $1? It's for 10 amps. What is with the sorting algorithm here? Yeah, because we go from look at this. We go from active, $1 and 4/10 of a cent, or sorry, 4/10 of a cent, and then $1.13, and then active again, and then 15 cents. I want the 15 cents. I don't need. Oh look, I don't have to. Wait, these are not even in order. What the heck is going on? DigiKey, what'd you do? Something's very wrong here. Taiwan Semiconductor Corporation. Okay. I mean, Taiwan, I guess, is fine. I guess. I don't know. Something's real wacky out here, man. There's something wacky's going on at DigiKey. What is happening? Okay, let's just stick with the brands that I'm used to. Vishay, Toshiba, Rome, Rectron, On, Microsemi. I mean, there's two here in the same one. That's a little weird. Kyocera, Infineon's always good. Diodes, I'll even take a Diodes. Borns, yeah, get on in. Comchip, I don't know what Comchip is. Alright, stick with these ones. I might pay a little bit more for these brands. What's happening? I think I just killed the webpage. I think I just beta tested DigiKey. What is happening? What is going on? Someone tell me what's going on. Is it working? Did it happen? Are we happening right now? What's going on? What even is this package? Let's just click on one of these and see what's going on, because I'm dumbfounded right now. Yeah, here's the unit price. What the heck? Okay. Maybe I should specify that I don't want DigiReal. That might fix it. Where do I specify that? I really screwed this thing up. Holy crap. There's usually one for package. Packaging. Oh, there's packaging. Okay. I don't know how I missed it. Bulk, cut tape. Tape and reel. Tube. Oh, wait. No, I don't want tape and reel. Good lord. Tape and reel is the big circular reel they put on the pick and place machine. That's not what I want. Why did it not? What is happening? What is happening? Okay, I'm going to start over because I really screwed this thing up. I don't know what I just did. It is really pissed. Okay, so what I'm going to do first off. Okay, now I'm back to the beginning. That was a mess. What is going on? Alright, maybe I should just do this in Chrome. I guess you're all going to see the last thing I accessed in Chrome. Or not. Ahaha. What is going on? Firefox is having a big problem with DigiKey. Alright, stack it. Okay. Let's try this again. Clamp on. Alright. Surface mount. I guess wettable flank, why not? Nothing wrong with that. I think through hole's unnecessary for this. I think it really is. Let's get the current, because that's a key, critical to quality parameter. I'm going to overbuild this a little bit, and maybe I'll go from... you know what? I'm going to see what options I have from 1 amp. I keep wanting to go from 1.5 amps on up, but I'll go a little higher. What's going? Okay. The alphabetical order here is totally different. That's very strange. Oh, in stock, please. Okay. I don't care about ROHS compliance. Not at the moment. Not making this into a product. Just a toy for me. See, now this is what you want to see, price. I don't know if there's a database fetching issue before, because it seemed like there was. Well, you know what? The fat lady hasn't sung yet, so let's just see what happens. Enter. Go, internet, go. Okay, yeah, it's still doing that weird thing. 88 cents at 100. Active 12 cents at 100. Wow, okay. Why is this on the top? That's not the cheapest price at all. Okay, well, if you want to buy a $130 diode, I know where you can get it. Okay, I'm going to actually break this off so it's not dominating the screen quite so bad. It's my dentist having an online meeting with me. Now you see who my dentist is. You'll now know where these pearly whites came from. Actually, I'm using the Invisalign stuff. It's expensive, but it's good. Oh, you know what's not good is this I'm looking at right now. This is a mess. What is even happening? All right, let's take a look at one of these. All right, let's get rid of all these brands that I'm not used to. Oh, Cree. Okay. Infineon. I've even used Kyocera. AmeriChete. Oh, AmeriChete. I didn't know you're in the diode game. Panasonic. Hello, welcome on board. Rome, get on. Yeah. ST, sure, why not? Texas, of course. Toshiba, why not? Vishay. I'll even use a Vishay. Nothing wrong with that. Now, it's not because his other brands aren't good. They might be. It's just I'm not familiar with them. I don't do a lot of diode shopping. All right. Okay. Still pushing this ST. Yeah, I see. Was it some sort of like algorithm mess trying to push these products on me? Why on earth should I use your part? As you slowly load, this thing is dying. I don't know. DigiKey servers. They're poor servers. See, I see 18 cents, 21 cents, 19 cents. It's all over the place. It's like it's only sorting on the single quantity price. You know? Because they're close, but they're not exact. Look, 16 cents. It's the lowest I've seen so far. Diode Schottky. It's a weird package. I really don't want to make a new package. This thing actually loaded yet? It doesn't even have a... It doesn't even have a price break. What the heck? Get this out of my face. Okay. What is this non-stock crap? Get out of here. Oh no, did I break it again? Yes. Apply. Thank you. Oh. That's a serious diode. I've already made enough. Look, 7 cents. 7 cents from On Semiconductor. Thank you, Lord. This is what I'm talking about. I want to pay $7 for this thing. See, 100 of these, $7. That's what you want. It's a normal package. It's just a normal, regular old SMA package. Oh my God, I'm putting that right in my bill of materials. Okay, that's going right here. So I'm going to say Schottky. I didn't specify Schottky, did I? Oh no. Yep, that's a general purpose. I was wondering why I was seeing more brands than I normally do. There goes my price break. Oh, okay. We got an automotive qualified 8.8 cent piece right here in a beautiful SOD 123. I think that's standard. From Nexperia. Automotive is a good sign. That means it can take some temperature, usually. I think that's the only... that, and probably it can sustain some abuse from static shock and other things like that. Probably has like cycle life and also lifetime guarantees of shelf life. You know, stocking it, in other words. Not that it can sit on a shelf for a long time. I think I'm going to go with this one, Nexperia. I mean, I don't have any... I have no... I have no confidence in the algorithm here for sorting price right now. But this looks fine. What's the forward voltage drop? You gonna tell me? Is it 1 volt? You think that would be like front and center? Forward current is less than or equal to 1 amp. Reverse voltage is 40 volts. What is the forward? Forward voltage is 500 to 640. I'd rather have more forward voltage. I'm going to keep this one in mind, but I'd rather have more forward... Sorry, not more forward voltage. I want less of that. I want more current, if possible. Yeah, so that's 1 amp. That's not great. I'd really rather be a little bit more... Oh, this is a SOD 323. I'm going to have to pay another penny or two. Is this a package that they have? Oh, it's an ST, so it's at least it's a name brand. Okay. All right, before I start wasting my time on that, let me just go make sure that there's a footprint for it. Also, I need to save my schematic because I'm paranoid now. I've made a lot of progress. Oh, no. Oh, no. Oh, okay, never mind. It's just this. Scared myself there. So SOD 323 or SC, what was that, 76, 79? 76. That's what you want. That last little pixel is always the hardest. Alright, I'm just going to cancel. I really did piss this thing off. Holy crap. Okay, I'm going to... Jank factor 5. I'm going to save. Okay. All right, now you can jank all you want. Let me see if this thing has a SOD 323. Oh, hey. All right, what are we talking about? Well, that's a weird looking package, but it's there. Hand soldering for all you noobs. I'm not too proud. Okay, cool. All right, let's do that. Okay, so you are going to be the Schottky. You are now a SOD 323. I'm really liking this. Years ago, I used this. Why is there no search feature when I'm looking for it? Okay, how about that? Like, there's a search feature in the editor, but there's no search feature in the... And when you're choosing it, you're just screwed. You just sit there and scroll through like an idiot. All right, hand soldered. I'm not too proud. I'll rather take a little W than a big L. Whoa. Okay. Now that was the hard one. Easy ones are to come. Well, I say that. You never know. I'm going to go ahead and save this guy, Bat60, whatever. I'm gonna put a link to it. I'm just idiot handing it. Schottky. Okay, now I've got that. If I have the URL, then I've got everything I need. All right, inductor. Let's do it. I thought I had middle clicked. Oh, that's right. That was during the jank session in the Mozilla Firefox, which completely crapped out on me. And yeah. All right, so inductors, coils, chokes. I want fixed inductors. There's 110,000 items. Let's see what we bring that down to. All right, we bring it down. We quarter it. We bring it down to a quarter of its value. So there's only 23 and something left. 23,393 left. See, look at all the different inductors you got. Molded, multi-layer, planar, thick film. I'll do a segment on shopping for parts at some point. Okay. Current rating. That's the only thing I really care about. This is the amount of current that's going to be coming through the inductor. Now, I could probably try and find a way to simulate this circuit, because the steady state is going to be 1 amp-ish, right? But the peaks are what makes me concerned. Okay, so I'm going to just grab 1.5 amps all the way up. Wow, 187 amp. I always love to see what the extremes on these things are. Like, what does a 187 amp inductor look like? Oh yeah, I should probably actually pick the inductance, right? Clear. I did not mean to click that. It was 6.8 microhenries for those playing along. I'm sure it's not that precise. Okay. Don't care. Alright, let's see what we got. Chunky boys. That's what I expected. I prefer surface mount. How much does that? That is alright. That doesn't really get rid of any choices. It knocks out like 30 of them. Okay. Oh, Worth Electronic is back. Hello, Worth. Diodes. I've used you guys before a lot. Big fans. Big fans. Look at that. Look at that headroom. Oh my gosh. Oh, I haven't sorted for price yet. All right. 100 units. What have you got? Ouch. I'm not paying $100 for these. Or am I? Oh, never mind. Okay, I'm definitely not. Here's an 18 cent. What is going on with DigiKey? What the F is happening? Look, 18 cents. It's like there's a bunch of crap in the front. Like, this is all crap. And then you get down here, and then you see like real prices. Okay, like these are actually sorted, apparently, kind of. All right, so what am I buying? What do I get? So for 18 cents, Delta Electronic. Hey, I know Delta. There's Diodes. That's very good. Okay, so in that range, in that price range, Chillison, I've never heard of them. Wire wound. I don't care about the series. Oh, sorry. Middle click going nuts. All right, so we got a clear amperage advantage on this row. Shielded, 52 milliohms. So the amperage is pretty much related. The amperage it can take has to do with the package it has, like how big it is, because dissipating power, but also what its resistance is, because that's how much power it's going to dissipate with I squared R. Okay. Package case non-standard. Yeah, a lot of these are non-standard. All right, Diodes, you win again. You usually do. I don't know what your secret is. It's probably just being super cheap. Probably with processes. Diodes sounds Japanese to me. Inductor. All right, last component we got to get is the fat capacitor, right? Right. That's easy. Easy cake. Get out of my face. Stupid menus. Easy cake. All right, we're not doing anything super fancy here, okay? So I'm just going to grab ceramic. Again, I'll do a segment on how to shop for capacitors and stuff like that later. It's every single category is kind of its own beast. All right, so mounting. Okay, capacitance. Let's go ahead and actually find our capacitance that we want. This one actually has a, I don't know, 8 to, I don't know, 15. I don't care. Boom. All right, whatever. Failure rate. Oh yeah, caps fail pretty regularly. Their job is to maintain an electric field between a potential difference. So, and that's as strong of an electric field as it can possibly hold. As it's kind of the guidance. A lot of 0805s so far, but I haven't sorted by price yet. So, 100. Again, the prices are screwed up. This is really pissing me off a little bit. Oh, Samsung. All right. So as you can see, these are about 3.7 cents per quantity of 100, which means that it's going to be like $3, $3 for all 100. That's pretty much standard. So the only difference between a lot of these is just the package. So this one was an 0805 slim, or sorry, low profile. 0603, 0805, so I can just easily put an 0805 here. Now I'm not marrying this part, right? But I'm grabbing it for now. I can change my mind later, but it's a capacitor. It's a, call them jelly bean parts. They're not really. It's not going to make or break your project. Now, if we're talking about aluminum capacitors or something that has an electrolytic, something with a little liquid inside, you know, something that's going to has a massive failure rate, and the price is going to very much determine your failure rate, then we're talking about something. But for these, I don't care. Oh yeah, I've been using my bill of materials over here to calculate the price of this project. I'm just going to throw the prices in real quick. At quantities of 100, you are Schottky diode, you are here. I need 100 y'all. Okay, inductor, I also need 100 of you. Don't have a price on you yet. Let me grab it. Where'd I put you? Here you are. Tayo Yuden, you were the winner. Okay. Alright, in you go. 20 bucks. 20 bucks. This stuff ain't cheap. Program headers are usually pretty darn cheap. That's not a big deal. I also haven't selected the part yet. So 1 microcontroller, 25 RGB LEDs, which surprisingly, oh yeah, they're about 100. So almost the entire project is the RGB LEDs. So if I were to just pop in here, go to data, oops, sorry, insert a pie chart, sure. I mean, that's not the most efficient way to do it. Let's go to subtotal, and then also these. And I'm just going to insert a pie chart now. Yep, all right, there you go. So it does it automatically now. So as you can see, the expenses here. So if I was a project manager, I would try to reduce the price of these LEDs as much as possible, because that is like almost 3/4 of the entire price of the project. I'm not going to haggle with my microcontroller guy, right? Which one is he, right? Microcontroller the microcontroller is the orange one. It's like one of the slimmest ones. The accelerometer, similarly, it's just only one of them. It's not worth it. LEDs would be where it's at, like the RGB LEDs. So it's nice to put stuff in perspective, okay? The cost of this thing is going to be about $157.92 at the moment. I still am not even close to finishing the bill of materials. There's going to be a lot more stuff. I haven't done any of the support circuitry for the microcontroller. I am just doing an RGB dev board, more or less. I think I'm actually going to make this into the main board. And I think I've got everything. Yeah, okay. Save your sheets. When you're done, save your sheets. Alright, and all I have to do is give myself a feeling of completion. You know, I'm not going to complete it because I've got to make a footprint for the I gotta make a footprint for the inductor. I'll do that off camera. You've already seen me make a footprint before. There's no reason to belabor the point. Alright. Let me go back to OBS Studio. Headshot. Okay. So, fun times. We've made a new board. Another day, another board, right? It took about an hour, which is about actually pretty quick. Especially when you're coming up with all the parts and selecting parts in the real time. If you're doing prototype development, it goes like that. We're just trying to slap something together, test it out. I want to see what this thing looks like. I want to see what this thing does, and see what these LEDs look like. I'm really looking forward to it, and I hope to see you there. All right, this has been the Alex with NASA. Subscribe, smash the like button, all that stuff. Do what you want. I'll see you guys later.